Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing the derivation of RIF, input resistance, with feedback for a current shunt feedback amplifier. The topic is from the unit feedback amplifier. The subject name is ECA. So, before going into the derivation, let us understand how to draw its block diagram and its equivalent circuit, which will be used for the analysis for RIF. The first two words can tell us what is the basic amplifier to be used. Current is the first word, shunt is the second word. Current. First word tells about the output, the second word tells about the input. At the output side, we do sampling. And what type of sampling it is done? Current sampling. If it is current sampling, the connections at the output are series connections. Current is sampled. So, what will be the parameter? Output parameter I0. Okay. The current is sampled at the output. The connections are series. At the input side, we are having shunt connection. And at the input side of the amplifier, mixing is done. Shunt mixing is done at the input side. If shunt mixing is done, what parameter is mixed? Current is mixed. So, we need to place a current source at the input side of the amplifier. Okay. So, if you see, the output is I0, current I0, and for shunt mixing the current source is to be placed. So, it is II. A current source which is delivering a current II. If you find the ratio of output by input is what? Gain. I0 by II, it is known as AI, current gain. If AI is the current gain, what is the basic amplifier to be used now? Current amplifier. So, we have used a current amplifier of gain AI and a feedback network of ratio beta. So, these are the two basic blocks. So, at the input side we are doing shunt mixing. So, what source is to be placed? Current source. So, we have placed a current source at the input side which is delivering a current II. Okay. What are the connections at the input side? Shunt. So, the feedback network is connected in shunt, that is in parallel to the amplifier. So, this is shunt connection. We have darkened the dots indicating that this line is connected to this line. It's not connected over here. So, the feedback network is in shunt at the input side because it is shunt mixing. Mixing is done at the input side. Now, coming to the output, current sampling. For current sampling, what connections are done? Series connection. The feedback network is connected in series at the output side. If series connections are there, what parameter is sampled here? Current is sampled and a load resistor RL is connected. Output current I0 is equal to IL. So, here the feedback, what the feedback network will do? It will take a part of output parameters. So, it will, what type of parameters fed? IF. So, IF, what it will do? What is IF now? IF will take part of I0 output. What is beta? Beta is a ratio, output by input. Output by input. What is output? IF. What is the input? I0. So, what is IF? Beta times of I0. So, this is a block diagram of a current shunt feedback amplifier. To do the derivation of RIF, input resistance with feedback, we should know the equivalent circuit of current amplifier which is drawn over here. So, current amplifier input is IS. When there is a current source, there will be parallel resistor, internal resistor of resistance value RS. It will be connected in parallel to IS. IS RS. Input circuit resistance is RI. At the output side, we are having a current generator II, current source. And then when there is a current source, what will be the resistor? It will be parallel. So, R0 is connected parallel to it and the resistor RL. This equivalent circuit how to draw this equivalent circuit of current amplifier we have done in the previous class. If you have any queries regarding it, you can see that video how to draw this one. But now for this class we have understood that you know a current amplifier and its equivalent circuit which we have drawn it directly. So this is a current amplifier. To this current amplifier we are placing a feedback network. Okay, what is the function of this feedback network? To take a part of output current. So it is taking IF. It is feeding IF current to for mixing at the input side. So this current amplifier, this negligible resistor RS is the internal source resistance of the IS, which is negligible. So it is taken as 0 and it is removed, and this is a diagram of a current shunt feedback amplifier. This is a diagram of current shunt feedback amplifier. So I hope now you have understood the difference between these two. This is current amplifier and this is current shunt feedback amplifier. The difference between these two is we have placed one more current source IF. Based on this diagram, IF is coming down. So we have placed the down direction for it. Okay, and other things are same. Okay, we have removed RS and placed, because RS is removed because its resistance value is very less, negligible value, so it is removed. So at the input side we are having three currents. If you look at this diagram, at the input side we are having three currents, IS, II and IF. II, IF are leaving currents. Here see, II and IF are leaving currents. So here IS is entering, IF and II are leaving currents. Resistor Ri at the output side AI, II, R0, RL. Okay, so we are having two definitions here now. One is Ri, this is the input resistance without feedback. Ohm's law you know, V is equal to IR. So R is equal to V by I. So what is Ri? Vi by II. And RIF is the input resistance with feedback. So it will be Vi by I as a total source current we need to take. So the difference is here II, this is IS. This is the input resistance without feedback and this is the input resistance with feedback. So this is the equivalent circuit of a current shunt feedback amplifier. So we can write the name of it. Ri is input resistance without feedback. Input resistance without feedback. And what is RIF? RIF is input resistance with feedback. We have to do the derivation of RIF now. The equation for this is Vi by II and this definition is Vi by Is. And what is IF here? What is the feedback current? Beta times of I naught. A part of output current is fed back. Okay. So these are the basic definitions you should know before the derivation. Now apply KCL at input side. What is KCL? Current entering is equal to current leaving. How many currents are there? IS, IF, II. So current IS is entering. If you take this node, IS is entering and these two are leaving. So we can write IS is equal to II plus IF. And what is IF? IF is equal to beta times of I naught. What is I naught? If you apply KCL at output side, so these two currents if you are taking, AI current is entering, I naught is leaving. So you can write I naught is equal to AI times of II. Okay, now substitute this one. Beta times of I naught. I naught is equal to AI times of II. So it take II common, 1 plus beta AI. It is coming to be as IS. So this is one equation, KCL at the input side. What is the definition of RIF? RIF is equal to VI by IS. So VI by IS, substitute this IS here, II by 1 plus beta AI. And what is the ratio of VI by II? It is RI, 1 plus beta AI. So RIF is equal to, this is RI by 1 plus beta AI. Okay. So this is how we do the derivation of a current shunt feedback amplifier. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.